is, it just keeps getting better and better.
Miss Mary, it's not working. It won't let me
Okay, I will work it. Project rule, see if I got it.
I have an internet trick that I don't get it. You can get all that tomorrow.
Fourth block's your last block.
No.
That's it, it's on the board.
So chain rule, y'all. Here's what I need you to think about. You do not have to write this down because you should, excuse me, look. What is the derivative of sine x? Cosine x. What is the derivative of cosine x? What's the derivative of tangent? If I'm tan, I've seen it twice. I know that's so silly, but I swear it's the only way I can remember it. Okay? Now, I want you to think, I have alluded to this with the chain rule. I want you to think of this as a new power rule. We know that we throw the power to the front, we write the function, we lower it by 1, and that was the original power rule, right? But what we have found with the chain rule is if this, it'll write the derivative of that. If it was u to the n power, what is that? N times u to the what? Attaboy, n minus 1. This is the new part. What do we have to do with the chain rule? What's always at the end?
The derivative of
The derivative of the quantity, right? Now, let's put it in this notation. If our function is u, the derivative of that is what?
1.
No. Let me say it to you like this. If the function is f of x, the next thing I write to denote the derivative is what? So if our function is u prime, that's the derivative of the function u. Okay? So from now on, that's what we need to be thinking. Power bump to the front, the function, lowered by 1, derivative of the function. You with me? It's the same thing we've been doing. It's the same thing we were doing, but it was always a monomial. Okay? So what's the function of, what's the derivative of x? 1. Remember that 1 was always there, but we really didn't talk about it until we started doing the chain rule. Okay? All right, so look how this is going to work with our trig functions. We're not going to think any longer that the derivative of sine is cosine and be done with it. We're going to think the derivative of sine is cosine u times what? Let me go back. Yes, you just said it. U prime. Write that down. When the function, remember Tim said, Miss Perry, we haven't done this yet. Yesterday on that worksheet, sine of 3x, and he said, we haven't done that. I said, you're right, and I had to mark them off your worksheet. This is how we could have done these problems. Okay? So then, the derivative of cosine, y'all, of u would be what? Negative sine u times, one more time, u prime. So all of our normal derivatives will just be followed by times u prime. You with me?
Yeah.
Derivative of tangent, if I'm tan what? I've seced it twice. I know that's incorrect grammar, but I'll look there. I ain't no English teacher. Clearly. I've seced it twice. Cosec it. Cosec it, it's bad if you cosec in a cot, right? Is that it? Yes. It's bad if you're cosecing a cot. Times what? Times u prime. I don't know what you talking about back there, but you stop it. None of that naughty stuff. What have I seeked? I've seeked the tangent. Always follow with times u prime. Folks, this would be a new card. And we figured out how to do this with the manila folders this morning. Okay? And then the derivative of cotangent. I don't know why this one is a little easier for me to remember.
Isn't it negative c?
Negative cosecant squared. It's just, I don't know why, but negative cosecant squared u times u prime. Get off that phone, get off that phone. Who's on their phone? Who's on their phone? Get off your phone, get off your phone. That was just fun. So get off your phone. Go ahead, Sierra.
Could you post a picture, if I made the cards at my house, could you post a picture of how you did the so that I can-
Yes, that would be something. Ooh, that would be something good for tomorrow. How do you really feel? Okay, hey, you guys are way too to be whining and complaining, right?
No.
Yes. I know, because you guys are awesome, right?
Yes.
Because you guys are being so freaking
No.
okay. See, stop that. Here we go. Woo! This is going to be so much fun, Katie. You ready? It's like, okay. Here we go. F prime. I love y'all. Have I told y'all that today?
No.
Okay, I love you. There we go. Sine of 4x. What the crap? What the crap? Shut to It do. It do. Use your new rules. What's it going to be?
Cosine.
Cosine x times 4, but no, we're going to make it look nice. 4 cosine x.
Where do the 4
Where did 4 come from? Remember, it's the derivative, it's your u prime. That's your u, okay? I didn't really substitute anything right there, did I? That one was pretty easy. Go ahead. It's all right. It's okay. It is. Oh, it is 4x. It is supposed to be 4x. Why? Let's first mistake I made all day. Dang, no. Did it yesterday. Erase that. My bad. Hey, what? Write this down. This is my bad. That's my bad. Okay? The rule is that the derivative of sine is cosine u times u prime, right? Because I did say u substitution. Thank you, Tim. What is your u?
4x.
4x. What is u prime?
4.
It's just like a little problem within a problem. Okay? That right there is set up. Now all you have to do is substitute. Okay? So watch. Let's fill it in. Cosine, what is my u?
4x.
4x. What is my u prime?
4.
4. Now, make it pretty. Thank you. Throw that 4 to the front, 4 cosine 4x. How is that? Better? Thank you. Do you see what I'm doing? Okay. This is what I found when I went back, and because I always try to fix my notes and make them better. When I went back and did it at the beginning of the week for this lesson, this I think is easier. It was easier for me this time, so I thought I'm gonna do it this way. You ready for the next one? I can tell you are. Calm down. Calm down. Hey, Webb. What's your u, folks?
X to the 3rd.
X to the 3rd. So what's u prime?
3x squared.
Do you guys agree with that? What's the rule? The derivative of cosine would be negative sine u prime, right on?
Mm-hmm.
Okay? Find the derivative and clean it up. All you're doing is substituting your u values. So
And I need a sign.
You ready? So what's your final answer? What's the derivative? Who's got it? Woo, wait a minute. Negative who? I'm sorry, you said negative sine of what?
Negative 3.
No,
Oh, she don't want the answer.
I don't want the answer, I want the answer before the answer. There we go. See, y'all didn't even flinch. When I said I want the answer before the answer, y'all were like, negative sine x cubed times what? And now give me the answer that is the answer. Listen, y'all. How many of you had that? High five. Don't you leave me hanging. Don't, look. What is that? Who wants a high five like that? Get on with your love. Don't high five me like that. That is weenie. High five. That ain't even a low five. That's under the ground five. Don't even do that. You ready for another one? Yep. Do them both. Do them. Do them. Woo! I'm so excited. Okay, what's my u in example 3? 3x. Then my u prime, everybody. 3. My rule says for cosine, negative sine u prime, right? So f prime of x is negative sine 3x times, and then I'm going to rewrite it, right? Negative 3 sine 3x. How many of you had it? Hands up. High five. Next, what's my u in 4? We are not going to flinch. What's u prime?
4x.
4x. We are not going to flinch. What's my rule? Sine. Don't do it. Cosine u times u prime, right? All right, here we go. That was f prime of u. F prime of x is cosine of, in parentheses, and u prime is 4x. Can I clean that up? What am I do with 4x? Go it to the front. Do I distribute? No. Okay. How many, hold on. How many of you had that as your final answer? Yes. That applies. Let's see. We don't have any more time. What do you think you would do with this just for kicks?
You would.
What would you do with the negative 2?
Distribute the 4x.
Let's leave it to the front. Leave it to the
What
front.
if it was an x?
Then, what if it was negative 2x times cosine of 4x? Then
Yeah,
you do what, KJ? Product rule.
How many questions?
400. Here's what I want you to do. No, watch. Watch, don't cuss me. Here we go. I see it. Yes, you would in your mind. I ain't stupid. Because in my mind, no. You guys are always angels with halos. Always.
Well, they didn't do anything.
You done come on, Tina.